Ready? Yep. Good morning, everybody. Welcome to our first meeting after all of our COVID stuff. I think we did a good job with the YouTube things. We had a few hiccups here and there, but overall, we did a good job doing that. One thing I really want to say is we're approaching 70 members. I think that's the highest we've ever been since I've been involved with this group. So we'll have a little meeting after this, but I'm going to get John from Electric Pump to let him get started on his presentation, and then we'll have a meeting right after that. So, John, want to come on up?
Good morning, everybody. My name is John Lito. I am with Electric Pump. Is it okay if I stand over here so I can see the screen? Can you still hear me okay? Can you guys hear me in the back okay? Yeah, that's a shame. Thank you for giving me the opportunity to be here today. Some of you I know very well. Some of you I've just met. Some of you I don't know at all. Some of you are never going to want to know me again after today. I'm going to talk a little bit about lift stations, retrofitting a lift station, maintaining a lift station. I am, like I said, I'm with Electric Pump. We're a vendor. We're a supplier. We're a contractor. We do repairs and maintenance on equipment on site and back at our shops. We are in the northern third of Illinois. We're in all of Iowa, all of North Dakota, South Dakota. We are in Minnesota and all of Nebraska. So we've got a pretty big footprint. We've got multiple shops. We have a great deal of experience and some very intelligent people that work with us. Unfortunately, you're stuck with me. So we'll just make the best of it today. Those of you who know me know that I am probably the least interesting person in the room. So for you to gain anything out of this presentation, please interact. Please ask questions. If you've got your experience has taught me tenfold over my own. So please share your experience. What is a lift station? We're going to start off with the very basics. A wastewater lift station is a pump station designed to move wastewater or sewage from a lower to higher elevation using a collection system. These pump stations are often used to move wastewater from residential and commercial facilities to their final destination, your wastewater treatment plant. Okay, so this is kind of generic. What are the components of a wastewater station or a wastewater lift station? A wet well to temporarily store the water, 2 or more submersible pumps. What I'm used to, you're always going to see on a municipal wastewater station, you're always going to see at least 2 pumps because the EPA/DNR is always going to want to see some redundancy. Is that accurate? Okay. Pump flow control, or in some cases sensors or transducers or probes. Piping, a valve vault, a control panel. Now valve vaults we're going to touch on a little bit here shortly. Some of the newer technologies and the newer way we do things, we're moving some of those components which used to be below grade, where you had to have a confined space to exercise your valves. We're bringing a lot of that out now. A control panel, a radio communication devices, radio being standard radio or cellular. Sometimes you can get them tied to SCADA, and a backup generator. We don't see that often, but you do see it. You see a lot of municipalities who they'll have one 10,000 watt portable generator that they use to back up 15 different lift stations. Right? You have the Meltrix connector on the side. The lift station pumps the wastewater through a pressurized pipe known as the force main, which conveys the wastewater to the ultimate discharge point at a higher elevation. This is a atypical float-based wastewater lift station. One of the few things that I noticed on this one is I almost never see power come in from above grade anymore. It almost always comes in below grade. Here are your floats over here. typical floats are 4. Almost always anymore we use a transducer, which is not pictured here, with a 4-float backup system. Here's that valve vault that we talked about, and of course your submersible pumps. Any questions or thoughts thus far? No? Really should have brought some more coffee. These are a few of the items we're going to cover in the next 4.5 hours. Just checking. Common problems with your pump stations. If you're in a dry pit or you're getting flooding, if you have a shaft-driven pump or you're having issues with the shaft drives, does anybody ever experience clogging of any sort? Nobody, okay. Selecting and sizing the right pump for your application. Okay, we determined that there is a problem, that some type of redesign or new equipment is going to be involved in the answer. How do we select that? So we're going to go through some of the criteria to select that equipment, the preventive maintenance actions. I see, and it's amazing to me, we're talking about when we look at lift stations and how important they are to the community that they service, and how expensive they are to install. The amount of maintenance that goes into keeping them functional, pretty minimal. Minimal. In fact, a lot of the municipalities that I go to, they have it's almost like if I don't see it, it's not broke. I don't have to fix it if I don't look at it. And then we're going to finish up with some monitoring and controls. Now, this is a good time to tell you a little bit about myself. I came to electric pump. I have a background in controls and electrical installations. I started off doing electrical work, carrying pipe back and forth from one end of a construction site to the other when I was a kid. Much better looking back there. And I just kind of progressed through and did electrical work for a long time. Finally got a job doing design, electrical design for MCCs, and that's what brought me to electric pump. A lot of the pump guys you're going to see today, a lot of the companies that you're going to see, they do controls, or they do communications, or they do pumps. I feel like I'm very blessed to work for a company that's got hands in all of those things. When you call me for an issue, I can send out a guy who can do all of those things. So it's a lot easier to troubleshoot. Determining the problem. So you call me up and it's 3:30 in the afternoon on a Friday, and says, John, my pump keeps tripping out. It's overheating. Something's going on. And we take it, we go from there, and you can tell I don't think this is a far cry from reality at all. Most of the times, the thing that called me out to a lift station in the first place, the reason I went there, be it a noise or an overtemp or some type of alarm, ends up being a symptom, but not the problem. Noise is tied to vibration, which may be tied to cavitation, which may be tied to clogging, which may be tied to wear. Everything is all hooked together. So pretty common troubles we see. I hope you guys all had a good breakfast this morning. The corroded cast iron. So when we go out to look at something like that, it's not that I go to do a cast iron inspection. Somebody calls me and says, hey, I'm getting some weird noises, or my flow rate's down. And it turns out that there's a lot more vibration, and you were getting blow-by on the discharge elbow because things aren't seated right, or they're not staying seated right. They'll start off okay, and then they move. And of course, the clogging, that's pretty self-explanatory. We'll get into that in more detail. And cavitation on the impeller. Show of hands, who's experienced cavitation in a lift station? Okay. It's kind of like it's going on a snipe hunt when you're looking for cavitation. It's one of the things that we find when we can't figure out what else is going on. And we're going to get into cavitation here in a little bit. Worst case scenario, I get a call at 3 o'clock in the morning. The entire station is shut down. Things are starting to back up into somebody's basement, and now we're in an emergency mode. You got a back truck out there. You're trying to get as much as you can out. You're paying me double because I'm sending a guy over there on the 4th of July or on Christmas morning, right? Far better to be proactive than reactive. Far better to inspect the stations before. Far better to have some type of maintenance plan in place than it is to wait for this to happen. I can't tell you how many times I've been told, well, we'll replace it when it breaks. We'll fix it when it doesn't work anymore. We'll pull it when it's non-functional. Because this is where we're at right now, everybody. This isn't the old picture, and I can tell you that because right now there will be cargo ships lined up in this channel. The lead times that we're experiencing are far past what I've ever seen them, and it's not because we have problems with supply or manufacturing or even shipping them across the ocean. It's because the 2 or 3 days it used to take to get from the Port Authority over to Customs is now 4, 6, 8 weeks for some reason. The lack of personnel being on site. Just can't get the ships unloaded fast enough and get everything over to Customs. That's caused some major turmoil in the last year. So back to the issue. Clogging is the most common operational issue in wastewater pumping. It reduces pump efficiency. It causes your pump to trip out. It increases operational and maintenance costs and environmental issues from overflow. Right, guys in the back? Just making sure you're awake. By the way, if you stay awake through the whole presentation, there is a cache of valuable electric pump prizes that will be awarded at the end here. I'm gonna pick on Moline because they're not here right now. When we're talking about operational costs, that's a real number, and it's a very significant number. And the smaller the municipality, the more significant that becomes. If you're a 3-man operation and you have to pull 2 guys out 2 days a month, 3 days a month, that's a problem. Over in Moline, they had a large lift station. I want to say it was a triplex station, 125 horse apiece. And right upstream from this was, I believe it was an auto body shop, a nursing home, and a care facility, we'll call it. They were having to pull all 3 pumps twice a week. So twice a week, they're spending 16 hours, 2 8-hour days, 2 men, twice a week. So 32 hours to keep that station running the way that it was supposed to. So we're not making stuff up. Well, I do make stuff up, but I won't for you. Soft clogging versus hard clogging. Soft clogging is a gradual buildup of solids and fibers at the leading edge of the impeller. When the pump stops, the buildup can be flushed back into the sump, and then the pump restarts. It works normally. We see this more and more with as flushable wipes become more flushable, I guess is the term I'm looking for. So if you have a flushable wipe, it's in a sheet. It's probably grand total on a baby wipe. There's 30,000, 40,000 feet of microfiber thread. Okay. Now this is it's designed to be flushable, so it comes apart. Now it's not like toilet paper. You put the toilet paper in the beaker, you shake it for 15 seconds, and it's gone. Right? There's a milky residue. These wipes will leave a little nylon thread, tiny nylon thread. Now the problem is that those nylon threads build back up where velocity slows in your collection system. So at the first elbow, at the first valve, at the pump itself. And when you're dealing with a standard pump, a vortex impeller, or even sometimes on a grinder impeller, anytime you have an edge, those threads are going to get caught on that edge, and that's what causes the soft clogging. It will decrease your flow over time, and it's intermittent, right? Pump stops, everything falls out, hopefully, and you start it back up, and it works good. And you go through this on and off. And a lot of the new technology that we utilize today, we use a system, it's got a torque sensor in the pump, right? So when it senses a more drastic pull on the pump, it'll back up and start up and back up and start up, and it'll do that 2 or 3 times to kind of clear itself, which works great for soft clogging. Hard clogging, that poor little guy, he never saw that coming. You get something in there and it just stops. Usually we'll see parts of a brick or a steel rod. We pull the rebar out. Anything that'll stop the pump right here, right now.
What is that, a duck?
I don't think so. I was looking at the feet there. Looks more like it's probably a pigeon, right? Pigeons are more difficult to get out than turtles. Turtles are a real pain in the keister. Vibration and noise, other common issues. They're pretty closely related. If you have noise, you have vibration probably somewhere. Results in seal failure, shortens your bearing life, and it can damage pipe and accessories. We were talking before about those worn down cast iron pieces and the claws. If you've got vibration, it's gonna show. Common causes of vibration or noise. Poor initial installation. I am not making this up. 2 days ago, I was at a site. It was a brand new flight pump. Had been installed less than a month. Installed by the contractor who got the job. I'm there. 2 of my techs are there. We've got people from the municipality are there. The contractor didn't show up for some reason. But lots of noise, lots of shaking, lots of vibration. We started the pump up to do a test, and the public works director from the municipality walked over to where the pump, it was a dry pit application, and half of the bolts that secured the pump to the discharge were loose and shaking. So installation makes a huge difference. Now, there's a lot of people with a lot of time and money. It doesn't cost me nothing to run trucks across the state. They have workmen. Instead of taking care of your emergency, they're tightening up a bolt. Loosened fasteners, they do come loose over time. Pump clogging, oops. And cavitation again. I'm building up. That's kind of, cavitation is going to be my climax. It's going to be our crescendo for the day. And unbalanced hydraulic parts. A lot of what we use today, almost exclusively actually, we use hard iron or high nickel content impellers, and we do that because they wear more slowly, right? With all the grit, sand, gravel that's in the system, if you don't use a high nickel content impeller, they just wear out too fast, and you don't get the production that you want. So you go with these hard iron impellers, and the trade-off is it wears much better, but it becomes more brittle. And instead of slow wear over time, you can get chunks off the front of your impeller. Okay, and that kind of unbalance or imbalance can cause vibration. Here we go, cavitation. When the impeller or propeller blades or vanes accelerate the fluid to pass the blades, low pressure areas are formed. If it reaches vapor pressure, the fluid vaporizes and forms small gas bubbles. When the bubbles implode in high pressure areas later, they cause a very strong local shock wave. However, sometimes that can present things that you think are cavitation aren't. We talked about that a little bit earlier. So and it depends on the install and the size of pump and the type of material used. A lot of times it'll sound like, is anybody a big fan of chocolate bars? I love chocolate bars. Nestle Crunch bars. The first time I heard cavitation, I thought I was hearing somebody eat a Nestle Crunch bar. It's just a weird sound. It caused that cracking sound. There was a vibration, and you could feel it. Instead of being a vibration when this is my make-believe pump here. Down here's the volute. Here's where I felt the vibration. Not up here in the bearing, right? And the heat was down here. Cold water, but I'm starting to feel heat down here, not up here. Now we found that issue early on because the pump was tripping out from over temp. So that heat was traveling up the pump, even with a cooling jacket installed, and was tripping out the over temp sensor on the pump. It damages hydraulic parts. Can you guys see this slide? Can you see the pitting in there? The one I'm talking about that happened just a week or so ago, it was a hard iron impeller, and it had only been running for a month. And we were starting to see cavitation that you could feel with your fingers on the impeller. So, what is cavitation? It comes down to net positive suction head. What's available and what's required. The pump needs to eat. Right? The pump's energized, the pump's running. These aren't made to move air, these are made to move fluids. And it needs to eat. If what's available is less than what's required by the pump to operate normally, it can probably will cause cavitation. There are some pretty easy fixes, short-term fixes. If you've got a VFD, throttle it back a little bit. Sometimes if you raise the water level in your wet well, that can solve the problem for you, just by adjusting a couple floats. Optimizing the inlet. The example I was giving you just the other day, it was an inlet problem, and it comes down to maintenance. It had a check valve in the line downstream, or just before the pump, and the valve had never been cleaned, replaced, or exercised. And so enough grit and sand had built up around that, it wasn't opening completely. And so it was starving off the pump. Clogging, soft clogging can be an issue. Adverse hydraulic phenomena. Generally that's a term that engineers use when they decided that they didn't design the wet well right. It's just some phenomena, we don't know. Motor overheating. Probably, I'm guessing, near half the service calls I get are from motors tripping out from over temp, because a number of things can cause it. Clogging. Every submersible pump, if we're talking a wet pit application, has got a motor submergence level. The pump has to be in so much water. Now, depending on the manufacturer, the cooling system, it can change pretty drastically from the top of the pump down to the very bottom of the volute. Changes in flow during operation, changes in power during operation. Voltage and current balance. Pumps are stupid. A pump will do everything that it can to pump everything that it can in the system that it's in, regardless of what the voltage is. So if you're running at 460 volt, and all of a sudden you drop a phase, right? Or all of a sudden you go from 230 volt to 208 volt. that pump is going to create more heat because it's going to draw more amps to compensate. It needs to create the watts to give you the horsepower, with your brake horsepower, which we'll talk about here shortly. So the pump is going to basically overheat itself. Not every pump, but most of the submersible pumps that you're going to see, the bigger ones anyway, are going to have some type of cooling jacket on it. And uneven phase power, we talked a little about that. Anybody ever had water hammer issues? Show me some hands. Just 3 of you? What happened in your case?
It was extremely loud and it sounded like a gunshot. Scary.
Yeah? How,
Pipes were banging pretty hard,
okay,
slamming.
sure. We don't see it as much today as you used to see it. I think it's probably because A, a better design, and B, because more people are using VFDs and those type of applications. So water hammer results when you have a flow of water going to, and then all of a sudden it's stopped, or it's caused to flow backwards. With a VFD, that becomes kind of a non-issue, or even putting on a spring valve where it shuts more slowly can solve that, mitigate that issue. Here are some of the ways to handle water hammer. Air chamber, surge tower. We do a lot with air release valves. They just seem to really help out a lot. And again, a slow closing valve or a spring valve and a VFD. All right, we're going to do a couple of case studies. Everybody ready? Yeah. All right. Customer has a problem with soft clogging. Picture below is an impeller. Can you guys see this impeller? Right? A lot of pitting and rust going on in there. After 6 months of pumping. Theoretically, when you look at it on paper, the MPSH required is exactly what it should be according to what's available. So we should be okay, but we're not. So knowing that, what's your initial guess? If you're to theorize, based on that, what would you tell me the problem is?
Too many solids going through the pump that it can't pump to it.
Sure. That's a good one. Anybody else? Brandy, I know you got an idea. Nothing? You're damn close. Damn close. Soft clogging. Too many solids. Again, so you're having fibrous material getting built up at the inlet and then slowing down the flow. In this particular case, they put a non-clog impeller in and saved the station. Unfortunately, I didn't get to build a whole new station out of it, which is what I wanted to do when I went there. We just changed out an impeller. Case study number 2. Customer has a problem with hard clogging. Picture below are wipes, shop rags, mop heads, and etc. clogging this impeller. This specific pump is a flight hard iron and impeller. This impeller doesn't clog. That's what I tell everybody. This one doesn't clog. This thing comes with a 2-year no clog guarantee. That's how sure they are that it's not clogged. It looks like a clog. So this was a mess. This happened to a buddy of mine, Steven, up in Minnesota. There's a body shop and 2 assisted living homes upstream of this lift station. Station wasn't being cleaned out regularly, and every time they'd pull a pump just to check it, make sure everything was okay, they put it back down. And anybody ever do body work on a car? I've done some very poor body work on a car. I've used a lot of fiberglass mat. Those little fiberglass fibers get everywhere, and they are impossible to clean up. So you just, when you hose down, they go right down the drain. Well, if you're doing that over and over, those pieces of fiberglass basically turn into a fish net at the bottom of a wet well. If that station is not backed out, and if you're not using something like this mixed flush valve to keep the product agitated, it just forms a net. So any diaper, mop head, rag, anything that would normally get pumped fine by a flight end impeller is now in a net, and that you can't fix that. So at the end of the day, what they did, this little mixed flush valve. Does anybody have one of these that they use? Yeah.
Only problem is, yeah, it'll keep it moving around, but if it starts to suck up the pump will start, chew it up, like all pumps. It's when the pump stops. And then when your flow drops off our transducer, and that stuff's halfway through the pump won't restart.
A lot of times you're right.
So you're pulling that pump. I mean, I got numerous pump stations, and it look like Cousin Hit's pulling them out because of all the rags and everything else on them.
Yeah.
And it's I got Spitalopolis, Flight, Simcoe, Gorman Rupp. They all work. They all cut up stuff when they're in operation. It's when they stop and they can't restart. That stuff's all wrapped up in there. We're constantly backing out lift stations. They look like bed mattresses in there, and just wipes and everything floating on top, which I'm glad it stays on top most of the time. But
Right.
it's just kind of nature beast, and actually we're starting to look at maybe putting a screen in front of one of our stations.
Sure. Trash basket or something.
So they have to.
So I have. I'm not gonna turn this into a sales presentation, but I do have a couple of answers for you. And if you give me a call later,
All right.
I'd be happy to take you out to lunch multiple times, and we can figure something out. On that note, so I love these mixed flush valves compared to the rest of the system. They're fairly inexpensive. The other thing that we see a lot of now, we talked about some of the programming that's going into lift stations now. Having a adjustable or automatically varying stop and start instead of your typical float system where it turns on at A and turns off at C. This time it starts, it's going to turn on at A +2 and it's going to turn off at C -3. And it's constantly varying. It does a couple of things that way. You get, your better submersible pumps will let you get right down into the very nitty gritty of the bottom, and without them overheating. And you're also eliminating, we're doing away with a lot of the grease ring. And that grease is really, God, that just, all those fibers that we talked about from the microfibers and the nylon, that grease just, it's the glue that holds it all together.
So that mixed flush valve is just by mixing, it's supposed to break up that? I don't understand what that has to do.
I actually had a video on here, but I took it off because I didn't think you'd want to see it. So this sits on the backside of one of the two pumps or one of the three pumps in the station. And all it's really doing is it keeps all the sediment off the bottom by mixing, and it keeps that water comes out on top, shoots up, so it's hopefully creating a vertical mixing, right?
So it's not allowing a mat to form, basically is what you're saying.
Right.
So it's like
Ideally.
a circulating
It
nozzle.
stirs it up. It keeps that water flowing. Spin it in the tank.
Yeah,
It really keeps it moving around pretty good.
yeah, yeah.
It's about as simple as.
They do work. In a situation like what you were talking about, there's other issues that other products or programs that we can use. All right, so we know there's a problem. Yes?
Is that running 24/7, that pump?
No. Okay, so on a mixed flush valve, goes on one of the two pumps in the station, right? So, and that pump isn't gonna run any more or less than it was before. All right? And you're not drawing any more power to use this either. Once it's installed, I think we had some in North Liberty, Iowa, that they finally rebuilt after 30-some years of service. They're kind of bulletproof. All right, we've determined there's a problem. Lisa's station is a piece of crap. We know it is. We've determined that it's got clogging issues. It's got cavitation issues. The dry pit floods out all the time. How are we going to fix it? That worked a lot better in the hotel. All right. So, that's Pirate John. The video that we're not seeing for whatever reason. Who's familiar with the pump curve? Okay, what kind of information do you extrapolate from a pump curve? Right?
Color size maybe.
Yeah. Yep. Anything else you guys can think of? Brake horsepower. Everybody know what brake horsepower is? The power required by the pump to operate at the best efficiency point. So I apologize, guys. I don't know why that's not working. It worked on my laptop. I blame you, the operator. So raise your hand if you've never seen a pump curve. Never seen one. All right. So we have I'll show you pictures later. The rest of you, you've seen a pump curve. You know what the BEP or best efficiency point is on a pump curve. That's the point of the curve, generally towards the middle of the curve, where the pump operates at its highest efficiency, head and flow. Okay. You have three different numbers that we use: AOR, POR, and brake horsepower. AOR is your allowable operating region. So basically, an AOR is any number on that curve. It could be from 50 to 150% of that BEP. Okay. A POR is the preferable operating region, and that could be 75 to 125% of that BEP. We do a lot of in-house engineering. We're generally within single digits of a best efficiency point when we pick a pump. It's just better that way, and we'll get into that a little bit here after the video that you're not going to get to see. You guys are really missing out. It's a great video. So, don't laugh. That was a good day for me. That was Pirate John. We were down, and that's my 50th birthday. I know what you're thinking, John. There's no way you're 50. But my significant other decided that she was tired of Bald John and got me a Captain Jack Sparrow dreadlocks and pirate hat. She didn't let me take it home. So TDH, the head, the vertical part of the curve, it is not tall, dark, and handsome. It is not too damn hilarious, although those are the first two things. If you Google TDH, which I did when I started selling pumps, those were the first two things to come up. TDH is total dynamic head. What is total dynamic head?
Static head, friction losses.
You're really good at this. You're not allowed to answer any more questions. So, TDH, static head plus suction head plus friction loss. Okay, so if you called me up and you said, John, I need 400 gallons a minute. I don't know what my TDH is, but I do know the elevation change is 32 feet. I know it's going in 4-inch old ductile iron. It's got 6 elbows, it's got a check valve, and it's got a gate valve. We can configure from that, easy for me to say, right, what your TDH is. And this part's going to be on the test. Nobody gets to go home until after they pass this test. The static head, down to up. The friction loss you were talking about, okay, this needs to write this all down. This needs to be memorized. This will be on the test. Or you can call me. It's entirely up to you. It's probably easier to remember my name and phone number than it is to. Some of you are like, I never want to hear from you again. I'd rather do the formula. Okay. What can we do to a pump that's going to impact that pump curve? It's all about the impeller. I can take the identical pump running at the identical speed and put 3 or 4 different impellers in there and get 3 or 4 speeds and get different head conditions. You can get, that all changes with the impeller. Okay? What doesn't make any difference at all in the pump's output? It's the first thing you tell me when you call me. You say, John, I need a pump. It needs to be super expensive. I want you to retire after this. Hey! Did you say that again?
I was trying not to.
Okay. Yes, the 2 things that I hear most are horsepower and voltage, which are initially, when we're picking a pump to design, the 2 things that matter the least. With the changes in motor design, especially now with the IE3 motors and the permanent magnet motors, what we used to do with a 10, 12, 15 horsepower pump, we can now do with a 5. So horsepower is dang near irrelevant. Types of impellers. Now, the impeller we pick is going to be based on the product that you're pumping. I'm a little biased. My favorite is going to be the end impeller, but we do sell a fairly significant amount of grinders, cutters, choppers. Vortex impellers, that's kind of a brand preference, and your multi-vanes. One of the things, we talked before about the accumulation of fibrous material and where it gets caught on a leading edge of an impeller. This impeller spins this way, okay? So there is no leading edge, which is why it's worked so effectively for so long. And changing the diameter of the impeller. Exact same pump, exact same operating conditions, 3 different size impellers. And you can see really where they make the difference is in the head condition. So being able to pick our best efficiency point, it gives us a lot of latitude. Holes, you're not going to see this as much in the size of equipment that we're going to use, or in sewage or sewer equipment. You see that more in water booster stations, agricultural equipment. All right, so when I'm dealing with an engineer, and we do deal with a lot of engineers, one of the things that they ask us for more and more all the time is, I need a pump curve that's going to illustrate different settings on the VFD. That's what this is. Same pump, same impeller, running at different hertz. Okay. And I can't remember the exact math off the top of my head. I used to think, well, if 60 hertz was full power and 30 was half, that you'd get half the flow. That's not how it works. But you can, from 60 to 45, you can about cut your power bill in half. So this is a vendor-specific performance curve. It's got your QNH, your pump curve on it. Every vendor does something very similar to this. Every manufacturer does something similar to this. Your input power, your pump efficiency, the overall efficiency of the pump. And you can see that right here, it is directly over our BEP. So where the pump is most efficient is directly over the BEP. And that's the BEP. And your limitations, your brake horsepower. So let's say you were going to, I can't, oh, yeah, we talked about this. All right, so you see your pump curve and you're like, well, here's my number, it's off to the left or it's off to the right. Why is it so important to operate as close to the BEP as we can? Why does one manufacturer tell you you can operate within 20% and another one tells you no, it's really got to be under 10? Operating the pump on either end of the curve has consequences. For flows that are far right of the BEP, the brake horsepower, holy cow. I shouldn't be allowed to play with these things. The brake horsepower of the pump will increase, increasing the power draw and possibly the motor size. NPSH will increase, resulting in a greater risk of cavitation. Higher flow rated result in higher suction energy. So I'm pushing the pump harder than it needs to be pushed, than it wants to be pushed. I'm trying to get more out of it hydraulically than it's designed for. And if I'm trying to do that, it's going to require more power. Okay. Let me ask, okay, so why is it bad to require more power out of a pump? Why is that a bad thing?
Energy costs.
Yeah. If I can run a different pump with a different impeller using the same amount of electrical power, why wouldn't you? Right? Get more flow for less energy used. Operating far left of the BEP. Clogging, because you're slowing things down too much. And a lot of times what you end up with is, instead of actually moving the product, you're recirculating the product in the wet well. Does anybody know, without, and there's another formula that I won't put up there, but what is the basic scouring velocity of wastewater pipe? Anybody know?
2 feet per second, right?
Yep, 2 to 2.5 feet a second. You want to stay. Now, we talked a little bit, or I mentioned a little bit about some of the new equipment and programming that's done. There are setups now where we can tell a pump to run at a maintenance speed for a lift station, and that may only be 1.5 feet or 1 foot a second. But we can also tell that pump that, okay, 3 times a day you're going to scour that pipe. So 3 times a day you're going to let that station fill up or get to your highest point, and then you're going to run full out and clean everything out. So there's a lot of different, technology has allowed us to do a lot of different things now that not only save us money, but really help with equipment life. Any questions? All right, who's got a preventive maintenance plan in place? Tell me what it is.
We go to every station daily. Do our normal readings. Here, listen to the pumps run. We run in hand a little bit. Check the flows, check the control panels. Some pumps have greasers on, grease them monthly, or whatever it calls for. But we're constantly checking amp rolls, stuff like that. That's when, at least once a month.
Wow.
We're there every day,
Okay.
except for weekends.
You wouldn't lie to a guy, would you?
No,
All right.
no, not on these. Get too many.
How many lift stations you have?
We get 10 lift stations in the field, and each sewer plant has stations at them. And we have 200 grinder pumps we take care of too.
Brother, we gotta get together.
It's gonna be a lot of lunches.
Yeah, lot. So, I've already mentioned that as a vendor, as a pump rep, I think that maintenance is probably one of the most important factors in the life of your equipment and the performance of your equipment. It is probably way underserved. You are an anomaly. I hear more than a guy who's got a maintenance plan in place. I hear the guys who says, we pull them when they break. So, everybody's got a million and one things to do, especially if you're from a smaller community and you're pushing the snow and you're mowing the lawns and you're trimming around the gravestones and you're patching with asphalt. You're doing all these other things, and now somebody wants you to go out and you've got 3 lift stations in your community, and you know it's going to take you half a day to go through all those things you just talked about. It's still important. All right, so the next 2 slides, you need to memorize these. The next 2 slides are the, it's okay to laugh out loud. When we do a service agreement, almost every vendor who's got a service arm does maintenance agreements. These are our points for maintenance agreements. These are something that we do annually. If you don't have the time to do what he's talking about, hire somebody to do it. We do these, and I am not making this up, pennies on the dollar. We do these for. This is the free oil changes for life when you buy the new truck. The only reason we do this is I want my sticker in your panel. I want your people to be able to call me when it hits the fan, when something goes wrong. I want to be your pump guy. So I'm willing to do all these things for less than what it costs me because I want to be important. Right? I need to be needed. Check electrical conditions of insulation and power cable and on all phases of the motor windings. You're going to do your resistance check with a megger. Check any loose or faulty electrical connections within the pump control panel. Anybody ever seen the black streaks inside the panel when you open it up? You don't see it as much now, but we used to see people build the panel, they put it right over the wet well, right? And there was no air break. So that gas is going to permeate in there and it's going to corrode the crap out of everything that's in there. Anybody ever experienced that? You have in the corner? Just didn't want to admit it, did you? Check amperage draws on all phases of the pump motor. Check voltage between legs. Check condition and operation of the motor thermal protectors. Okay, every single pump manufacturer that I am aware of requires, if there's going to be any type of warranty involved, that your thermal sensor and leak sensor be hooked up to something. Okay, if you do not do that, Flight's got a little thing they call a mini cache you got to hook to. Everybody's got their own version of it. If you don't do that, there's no warranty. Doesn't matter how much you paid for the pump. It doesn't matter how new it is. Check condition of the seals. Pull the pump. Check it visually. There's that leak detector that we talked about. Check condition of the oil. Change the oil if needed. Check, and this is the easiest one. Check for worn or loose impeller. When I do a service agreement for you, we give you a report. Hey, this is what your equipment looks like. You're at 80% life or you're at 60% life. A worn or a damaged impeller is the easiest thing to see, the least expensive fix 9 times out of 10 to get you back to where you want to be operationally. Check for noisy bearings. Check for damaged or cut cable. Anybody ever have the dry end of a pump go short to ground? You ever seen that happen?
Say it again?
When your dry end, your motor end shorts to ground. You get moisture in there and everything, the whole entire thing shorts out. You're toast, right? This is an expensive fix. Huge, huge. Your stator's shot, your rotor's shot, the internal components are shot, and 9 times out of 10, it is because of a 1/2 inch, 1/4 inch slit in the power cable or the control cable. I had a new installation and had just been in there 6 months. Got it back to the shop. They're like, we want to make sure this is under warranty. I'm like, well, there is a warranty in place here, but not on the cable. There's no warranties on cables because that's the first thing a contractor screws up. Is they'll catch the cable on something, or they'll set the pump down on the cable. It'll cause that. Now, in this case, the contractor knew he had done something because they wrapped the crap out of the cable with electrical tape. Yeah. So what happens, your pump comes on, turns off, comes on, turns off, comes on, turns, so heat, cold, heat, cold, heat, cold, and it sucks the moisture through the cable into the dry end of the pump. Okay. So that was an easy fix. We could have just replaced a piece of cable. You could have even cut it off. They had plenty of room, but they never did. Check and clean, check, and reset your level sensors, just like you were talking about with your floats, or your probe or transducer. Reinstall pump and check for leakage. If there has been vibration or movement or those claws have eroded, this is where you're going to see it. Yeah, you're going to see the blow by when the pump's reinstalled. And check the operation of the pump. So the predictive maintenance, that's usually using a Megger, something where we can tell how much varnish is left on the windings. That's a good way to tell how much life is left in that motor, and sump cleaning. All right, how much time I got left? I got another 3 hours of material. We can go all day if you want.
It's 10:08,
What time did we start?
about 9:08, I would say 9:10.
All right, we'll do this quickly. Monitoring the controls. We talked about DFDs and how more widely used now they were than they used to be. I told you I came from the electrical world 25 years ago when I'm looking at my very first VFD. That thing was like 20, 30 grand, and it was for a 4 horsepower motor. It was only your big industrial accounts could afford to use one, and they saw benefit from it because it saved them that much money in energy consumption. Today, I stock in my shop in Des Moines everything up to 125 horsepower VFD on the shelf, both voltages. They've just got so much less expensive. Sump cleaning, we talked about how important that is. There's your before, there's your after. Still looks kind of gross to me. Soft starts, never see them anymore. I bet I see 2 or 3 soft starts a year. Just VFDs have gotten so much less expensive and easier to use. This is a beautiful panel. Is that not a beautiful panel? That's made by StarNet. It's one of the subsidiaries of Electric Pump. Everything in the sun. You've got your communication devices. You've got your sensors. Everything's in there. 2 basic problems with this control panel. One, to gain access to the low voltage side, I need to put myself right in front of the line voltage, right? That's 460 volts right there. I'm looking at a 24 volt ice cube relay, but I'm right in front of 480 volts. And 2, whatever the weather is, and I don't know if you've ever noticed this, when I get called out, weather sucks. It's raining, it's snowing, it's sleeting, it's 142 degrees outside and humid. Here's a same thing, only different. This is a single phase station. You can tell you only got 2 pole breakers up here. You do have a hookup for a portable generator, and you have the device here to keep you. It's just a piece of metal. It keeps you from running the generator and the line power at the same time. You can also tell that it's got the capacitors in it. All right, so super brief. NFPA 70E. Anybody have any knowledge of, use of, discussion around? This is something you guys ought to consider doing a presentation on. We have people in our company that do nothing but NFPA 70E, arc flash safe or arc flash compliant structures and control panels. It is an 8-hour presentation. You do get credit for it. Basics are, for a knucklehead like me, I should never be in front of anything more than 50 volts. Okay? Now, you can't do that on a traditional panel because you got to open the same door. Whether you're getting a 460 or you're getting a 50, it's the same door. It's the same dead front. And not in something like this. Everything is compartmentalized and sealed. You'll also notice that here's your heater down here. The vents for the VFDs are on the side, not in front. As a guy who came up in the electrical world, I've seen all the videos and I've been to the safety trainings and I've seen covers blown off and flame come out the vents with people standing in front of it. It does happen. So arc flash compliance is to minimize all those issues for you. The other thing that you'll notice, so you open up the panel, right, and you turn off the main breaker or the main disconnect in there. Does that mean there's no longer 460 volts in the panel? Still there, right? Still on the top side of that breaker. If you, on something like this, if I shut that breaker down, there's no power in that panel. It's dead. Shunt trip type setup. This just kind of illustrates that. Low voltage and line voltage, different sections. Here are some of the buildings. My favorite is a little 8x8 building because you can get an arc flash compliant motor control center in there, and you can take your valves out of the valve pit and put them in here. So if you're designing a new station, you're crazy not to utilize this. It saves so much money, and it just puts you in a better spot. There's no confined space for this. One of the first things my guys are going to ask you when they pull up to your place to do a retro is, how often do you exercise these valves? 9 times out of 10. Hell, 99 times out of 100. Never. Right? We've run into that, Lisa. Nobody's touched this thing in 30 years. Do you expect that valve to work? Do you expect it to hold? So putting them all above grade sure makes it a lot easier. The befores, I just put these pictures up here because I wanted you to kind of get the gist that it's not a one-size-fits-all when it comes to retrofitting a lift station. Every single type, style of station, every plumbing issue needs to be handled differently. There is no, if anybody tells you, hey, I've got one problem for every need when it comes to wastewater pumping, I think they're misleading you. Here are the afters. There's that little building I was telling you about. Here's a programming center, the HMI that we talked about before. Now this one I left, this picture's only halfway done. So they took out the regular dry pit pump and they put in a flight submersible here. And what happened, this station flooded. And it flooded on more than one occasion. You put a dry pit submersible in there and you take the controls out of the dry pit and you put it up on top. Now that thing can flood every day. Makes no difference at all. So why do we do everything that we do? At the end of the day, I want to feel like I made your life easier and I did something good for my environment, for my planet. I want my grandkids over here. Those are truly my grandkids. They're smarter and obviously significantly better looking than I am. But I want them to be able to go back to the same waterways, the same lakes, the same ponds that I went to. And I think it's our job to make sure that that happens. So, thanks everybody for letting me share. I hope everybody stayed awake. Everybody gets a koozie. It's a good day. Thanks.